Hello, and welcome to Boring Science to Sleep, a quiet place where science becomes slow, soft, and easy to drift through. Tonight, you're going to gently leave the familiar warmth of Earth, move beyond the planets you already know, and slowly enter the enormous space between the stars. You are not here to learn everything, and there is nothing you need to remember. You can simply listen, breathe softly, and let the distance unfold around you. Before you settle in, if you truly enjoy these calm journeys through interesting facts about science and the universe, you're welcome to like this video and subscribe only if it feels right for you. And when you're ready, let me know in the comments where you're listening from and what time it is right now. It's always a quiet joy to imagine all these different places becoming still together. Now dim the lights, perhaps let a fan hum softly somewhere nearby. Settle into whatever position feels comfortable and let yourself drift slowly outward, beyond the familiar planets, toward the first quiet stars. You can begin by imagining that you are simply floating above Earth. There is no need to travel quickly. Below you, the planet turns quietly beneath a thin layer of atmosphere, blue and white and softly illuminated by the sun. The oceans reflect a little light. The clouds move almost imperceptibly. Somewhere below them are cities, forests, mountains, and quiet rooms where other people are also beginning to rest. But from here, from this gentle distance, Earth already looks very small. And as you slowly move farther away, the familiar shape of your home begins to become less distinct. The moon remains nearby for a while, following its patient path around Earth. Then Earth becomes one small sphere among the darkness, and the moon becomes only a tiny companion. Farther still, the other planets begin to appear. Venus, bright and cloud-covered. Mars, small and reddish. The distant giants, slowly turning in the cold outer reaches of the solar system. And then, beyond the planets, something begins to change. There are fewer familiar objects. There is more darkness. The sunlight becomes softer, not because the sun has stopped shining, but because you are moving farther away from it, into a region where its light spreads thinner and thinner across an enormous space. You can still imagine the sun behind you, shining steadily, sending light outward in every direction. But now you are beginning to understand something quietly important about space. The solar system is not a crowded place. The planets occupy only tiny islands within an immense ocean of distance. Between one planet and another, there can be millions of kilometers of almost nothing. And beyond the outer planets, that emptiness becomes even more profound. You continue drifting. There is no sound here, no wind, no rushing air, no footsteps, only the imagined feeling of weightlessness and the distant memory of sunlight behind you. Eventually, you cross into interstellar space, the broad and quiet region between the stars. It is not completely empty. There are tiny amounts of gas and dust scattered through it, including individual atoms of hydrogen, along with particles that have traveled away from stars and clouds. But compared with the spaces you know on Earth, it is extraordinarily sparse. You could imagine a room larger than any building you have ever seen, and then imagine placing only a few grains of dust inside it. Even that would be far more crowded than much of interstellar space. And this is where the scale of the journey begins to change. The planets are no longer your main landmarks. Now, the stars become the distant lights you are moving toward. One of the nearest stellar neighborhoods lies around a group of stars called Alpha Centauri. There are 3 stars here, bound together by gravity, moving through space as members of one small stellar family. 2 of them, Alpha Centauri A and Alpha Centauri B, are somewhat similar to our Sun in their general nature, while the third, Proxima Centauri, is smaller, cooler, and much fainter. Proxima Centauri is the closest individual star to our solar system, and even though it is our nearest stellar neighbor, it is still unimaginably far away. Its light takes a little more than 4 years to reach Earth, so when you look toward Proxima Centauri, You are not seeing it as it exists at this exact moment. You are seeing light that began its journey more than 4 years ago. You can let that thought become very quiet. A single photon of light leaves the star. It travels through the darkness. There are no roads, no signs, no walls, nothing to guide it except the structure of space itself. And after more than 4 years of traveling, that tiny piece of light finally reaches Earth. Perhaps it enters a telescope. Perhaps it touches a camera. Perhaps it reaches your eyes on a clear night. And for just a moment, a tiny message from another star becomes part of your own experience. Around Proxima Centauri, scientists have found evidence for planets. One of them, known as Proxima Centauri B, is especially interesting because its orbit places it in a region where temperatures could, under suitable conditions, allow liquid water to exist. But that does not mean that life has been discovered there. It does not mean that the planet is another Earth. It simply means that, from the limited information we have, there are circumstances that make the world worth studying, and perhaps that is enough. You do not need an answer tonight. You can simply imagine the planet moving quietly around its small red star. The star rises in its own distant sky. The planet continues along its orbit. Light travels outward, and somewhere, many years later, that light may reach another world. There is something strangely peaceful about this. A planet can circle a star for billions of years without anyone watching. A star can shine through the darkness for longer than any human life, and the space between them can remain almost completely silent. You continue drifting farther from Earth. Behind you, our solar system becomes smaller. The sun becomes one point of light. Earth becomes impossible to distinguish without help. And ahead of you, Proxima Centauri remains only a faint red star. You have traveled an enormous distance, and yet you have barely begun. There are other stars beyond it, other systems, other planets, other quiet worlds that may never be visited by a human being. For now, you can simply remain here for a moment, suspended between the familiar light behind you and the distant lights ahead. There is nothing to reach, nothing to solve. The stars can remain where they are, and you can simply drift with the darkness between them, because beyond this first quiet neighborhood, there are worlds unlike anything you have ever known. You remain there for a little while, floating between the stars. Behind you, the sun has already become just another point of light, and ahead of you, Proxima Centauri glows faintly in the darkness. The star is small, its light is reddish, and somewhere around it, a world continues its quiet journey through space. You cannot see the planet with your eyes. You cannot stand on its surface. You cannot hear its winds or feel whatever atmosphere may surround it. And yet, from the tiny changes in the light of its star, from the delicate movement of the star itself, astronomers can begin to sense that another world is there. This is one of the quiet wonders of modern astronomy. A planet does not have to shine brightly for us to know that it exists. Sometimes, all it needs to do is pass between us and its star. For a brief moment, the star becomes just a little dimmer. Then the planet continues along its path, and the light returns, again and again. A tiny change in brightness, repeated over time, can become a clue. Another method is even more subtle. A planet pulls gently on its star with gravity, causing the star to move by an almost imperceptible amount. The star does not seem to wander dramatically. It simply shifts back and forth, almost as if something invisible were quietly holding its hand. From that tiny movement, astronomers can infer the presence of a planet. You can imagine how strange that is. A distant world may be millions or billions of kilometers away, completely hidden in the darkness, and yet its gravity can leave a tiny signature in the light of its star. The planet itself remains unseen, but its presence can still be felt, and once astronomers begin looking in this way, the night sky becomes filled with possibilities. One nearby example is the red dwarf known as Wolf 1061. It is a small, faint star, much less massive and much dimmer than our Sun. To your eyes, from Earth, it would not be a bright, familiar point like Sirius. It would be hidden among the many faint lights of the night. And yet, this quiet little star has its own planetary neighborhood. Several planets have been found around it. The closest one, Wolf 1061b, moves very near its star. It completes an orbit in only a few Earth days. So close is its path that the planet may be tidally locked, meaning that one side could remain facing the star while the other side turns away. You can imagine the difference. On one side, the red star would remain fixed in the sky. There would be no ordinary sunrise in the way you know it, no familiar morning slowly brightening into afternoon. The star would simply remain there, shining over one side of the world, and on the opposite side, the sky would remain turned toward darkness. Between these two regions there might be a narrow boundary where day and night meet, a world of permanent light on one side, permanent darkness on the other, and an endless planetary rotation that has settled into a very unusual rhythm. But this first planet is probably not a gentle place. Its closeness to its star exposes it to intense radiation and powerful streams of particles from the star. Any atmosphere it once possessed may have had difficulty surviving for long. So we move outward, just a little, to another world. Wolf 1061c. This planet is farther from its star. Its orbit takes roughly 18 Earth days, and it receives less energy from its star than Earth receives from the Sun. It is considered a potentially habitable world, but those words need to be held very gently. Potentially habitable does not mean inhabited. It does not mean that forests grow beneath an alien sky. It does not mean that oceans shimmer beneath clouds. It simply means that, under certain possible conditions, temperatures and other factors might allow liquid water to exist, and even that remains uncertain. Perhaps the atmosphere is thick enough to hold warmth. Perhaps it is thin. Perhaps the surface is very different from what we imagine. We do not know. And there is something peaceful about leaving that question open. You do not need to decide what the planet looks like. You can simply imagine it turning quietly around its small red star, a world several times more massive than Earth. A world receiving a softer amount of energy, a world moving through the darkness while no human being watches from its surface. And perhaps somewhere beneath its distant sky, if conditions are suitable, water could exist in liquid form. Not necessarily an ocean like ours. Not necessarily rain falling on continents. Just water, in whatever quiet form the physics of that world allows. This is where the idea of an exoplanet becomes more beautiful than a simple list of distant planets. Each one is a different experiment performed by nature. Change the size of the world. Change the distance from the star. Change the atmosphere. Change the amount of sunlight. Change the pressure. Change the temperature. And the same basic ingredients can become something completely unfamiliar. Some worlds may be dry and rocky. Some may be wrapped in thick atmospheres. Some may be covered by oceans deeper than anything on Earth. And some may wander through darkness without a star at all. Imagine one of those ocean worlds now. Far away, beneath a distant sun, you might have a planet where water covers much of the surface. There may be no familiar continents stretching toward the horizon. Instead, there may be an immense blue darkness extending for hundreds of kilometers downward. As you descend through such an ocean, sunlight would gradually disappear. The water would become colder in some regions, warmer in others, and the pressure would slowly increase. Far below, the water could become compressed into unfamiliar forms of ice. Not because the world is simply freezing, but because pressure itself can change the way water behaves. You would not need to understand the chemistry to imagine it. Just imagine descending. The surface becomes distant, the light becomes faint, the blue becomes darker, and eventually The ocean becomes a quiet boundary between the atmosphere above and the hidden interior of the planet below. Somewhere beneath all that water, a rocky world may remain. Perhaps. We do not know, and that uncertainty is part of the beauty. Another world, another set of conditions, another quiet possibility. Even a planet that seems similar to Earth can be deeply different. Even a world in a region where liquid water might exist may have no life at all. And a world that looks strange to us may still possess an atmosphere, an ocean, a hidden interior, and a history stretching back billions of years. The universe does not seem to have one preferred way of making planets. It makes rocky worlds beside red stars. It makes frozen worlds far from warmth. It makes ocean worlds beneath distant suns. It makes worlds that show one face to their star forever. And it makes worlds that wander alone through the darkness. You remain suspended among them for a moment. There is no need to visit every one. There is no need to memorize their names. It is enough to know that beyond the solar system, the darkness is not empty. There are worlds moving silently through it. Worlds too distant to touch, too faint to see directly, yet close enough for their gravity and their passing shadows to leave tiny traces in the light of their stars. And as you drift a little farther, you begin to notice that the planets are only part of the story. Because before a world can have an ocean, an atmosphere, or a quiet surface beneath distant light, there must first be a star to warm it. And stars, too, have their own long lives, their own slow changes, and their own gentle endings. So you can let the distant planets continue turning behind you, while ahead, the stars begin to grow larger in your imagination, glowing softly in the dark. You can let the distant planets continue their quiet orbits for a while. Somewhere behind you, a small world circles a faint red star. Perhaps it is rocky, perhaps it is covered by an ocean, perhaps it has an atmosphere, or perhaps most of that atmosphere has slowly drifted away into space. There is no need to decide. The planet can remain mysterious, and as you drift a little farther away, your attention slowly moves from the worlds themselves to the stars that hold them in their gentle gravitational embrace. A star can look so simple from a distance, just a point of light, but every point of light you see at night is the visible surface of a long, slow process. Deep inside a star, enormous pressure and heat allow very small particles to come together and release energy. That energy begins deep within the star and slowly works its way outward. Eventually, some of it escapes as light, and that light crosses the darkness until it reaches another world, you. A star can therefore be thought of as a very slow source of warmth and light, shining for millions or billions of years. Some stars are small and quiet. Some are enormous and restless. Some are young. Some are ancient. And some have already reached the end of the part of their lives when they shine in the familiar way. The smallest stars can be among the longest lived. Red dwarfs, for example, are much smaller and cooler than the sun. They shine with a soft reddish light, and because they use their fuel very slowly, they can remain active for extraordinarily long periods of time. Proxima Centauri, the small red star you visited earlier, belongs to this family. From a distance, it seems almost delicate, but its life may stretch far beyond the lifetime of larger, brighter stars. You can imagine a red dwarf glowing quietly in the darkness, not rushing anywhere, simply continuing to shine. Its planets circle it, its light travels outward, and the star continues through time. Some stars, however, begin their lives with much greater energy. They are larger, hotter, and brighter. They can live much shorter lives because they spend their internal fuel more quickly. One such contrast can be found in the Sirius system. Sirius A is a bright, blue-white star, easily visible from Earth, but beside it is something very different. Sirius B is a white dwarf. It is the compact remnant of a star that has already passed through the major stages of its life. Imagine taking a star and allowing its outer layers to drift away. What remains can become extraordinarily dense, with much of the original stellar mass compressed into an object only a little larger than Earth. It no longer shines because of the same deep process that powers an ordinary active star. Instead, it gradually cools over immense stretches of time. You can picture Sirius A shining brightly beside its much smaller companion, one star still in the familiar part of stellar life, the other carrying the quiet memory of a star that has already changed. And there is something beautiful in that contrast. The universe does not erase everything that ends. Sometimes it leaves behind a smaller, quieter version of what once was. Farther away, another kind of transformation is taking place. A star can become so large that its outer layers expand enormously. The star cools at its surface and takes on a reddish appearance. It becomes a red giant. Imagine the star slowly swelling outward, its outer atmosphere becoming vast and thin, extending far beyond the compact shape it had during its younger life. Inside, the star continues changing. Outside, its atmosphere can rise and fall in slow pulsations. The entire star may seem to breathe, expand, contract, expand again, not quickly, not dramatically, but over long periods, in a rhythm so slow that a human lifetime would capture only a tiny part of the movement. Some red giants also lose material through powerful stellar winds. Gas and dust drift away from the surface and spread into space. A star can therefore become both an ending and a beginning. The material it releases does not simply disappear, it becomes part of the surrounding space. Later, that material may contribute to clouds from which other stars and planets form. In this way, the life of one star can quietly become part of the birth of another. You can imagine a vast cloud of gas and dust drifting through darkness, carrying elements that were once inside an older star. There is no sharp boundary between one generation of stars and the next. The galaxy is constantly recycling its material. Stars are born, stars shine, stars change, stars release their outer layers. And sometimes, when a massive star reaches the end of its life, something much more compact remains, a neutron star. Here, the scale becomes almost difficult to imagine. A neutron star can contain more mass than the Sun, while being only around the size of a city. The material has been compressed so intensely that ordinary ideas of density begin to feel almost meaningless. You can imagine the mass of a star gathered into a space small enough to cross in a short drive. And some of these objects rotate very rapidly. As they turn, beams of radiation can sweep through space. If one of those beams happens to pass toward Earth again and again, telescopes can detect a regular pulse. This is a pulsar. A pulsar can therefore appear to us like a distant cosmic lighthouse. Not because there is an actual lamp turning in space, but because the rotating neutron star sends its radiation outward in a repeating pattern. Pulse, pause, pulse, pause. The rhythm can be remarkably regular, and so, after drifting among distant planets, you have now moved through several different lives of stars. The quiet red dwarf, glowing for an almost unimaginable length of time. The bright star like Sirius A. The white dwarf, carrying the memory of an earlier star. The enormous red giant, slowly expanding and releasing material into space. And the tiny neutron star, turning through darkness and sending its pulses outward. Each one is made from the same broad cosmic ingredients, yet their lives are shaped by differences in mass, temperature, internal pressure, and time. A star is not simply a light in the sky. It is a process, a long transformation, a changing balance between gravity pulling inward and the energy created deep within pushing outward. For a while, the balance can remain remarkably stable. Then, slowly, the balance changes, and the star changes with it. You can let that thought settle quietly. Nothing in the universe needs to remain exactly as it is. Not planets, not stars, not even the great structures of galaxies. Everything moves through time. Everything changes slowly. And sometimes, the remains of one object become the beginning of another. Far behind you, the small red stars continue shining. The distant planets continue turning. The white dwarfs continue cooling. The red giants continue breathing. The pulsars continue their quiet rhythm. Pulse, pause, pulse. And somewhere ahead, among all these distant lights, there are objects where gravity has become deeper still, places where matter has been compressed beyond ordinary intuition, and where even light itself can find no easy path outward. You do not need to hurry toward them. For now, you can simply remain suspended among the stars, listening to their quiet rhythms, while the darkness around you grows a little deeper. You can remain among the stars for a little longer. The pulsar behind you continues its quiet rhythm. Pulse, pause, pulse. Its light travels outward through the darkness, crossing distances so large that the meaning of distance begins to feel different. And somewhere ahead, gravity becomes deeper. Not suddenly, not violently, just gradually, as you drift toward one of the strangest kinds of object known to exist, a black hole. The name can sound dramatic, but there is something much quieter about a black hole when you begin to understand it. It is not a hole in space like an empty tunnel. It is not a cosmic vacuum cleaner, reaching out and pulling everything indiscriminately toward itself. From far enough away, a black hole's gravity behaves much like the gravity of any other object with the same amount of mass. A planet can orbit it. A star can orbit it. Even a planetary system could, in principle, remain in stable motion around it if the distances and conditions were suitable. So imagine yourself far away from one. You are not falling. You are simply drifting through its neighborhood. Around you, the stars continue along their paths. The black hole itself may be invisible. There is no bright surface, no solid world to see, only the effect of its gravity, quietly shaping the paths of things around it. And then, perhaps, you begin to notice something glowing, a faint ring of light. Then another layer. Gas and dust are spiraling inward. This material is called an accretion disk, but you can simply imagine it as a vast, slowly turning river of matter circling the darkness. The material does not immediately disappear. It moves. It circles. It rubs against itself. As it falls deeper into the gravitational field, it can become extraordinarily hot. The darkness at the center remains invisible, while the material around it can shine brightly. This is one of the quiet paradoxes of a black hole. The black hole itself does not need to glow for its surroundings to become luminous. The darkness can reveal itself through the light moving around it. And if you were watching from a safe distance, there would be no sound, no roar, no cosmic scream, only light, moving in curved paths around something you cannot directly see. At the center of a black hole is a boundary called the event horizon. You can think of it as the point beyond which there is no ordinary path back outward. If something crosses that boundary, light itself can no longer escape to the outside universe. This does not mean the boundary is a physical wall. There is no surface to touch. It is simply a boundary in space and time, marking a region from which the outside universe can no longer receive information in the usual way. You can let that idea remain simple. A boundary, a one-way edge, a place beyond which the darkness becomes complete. And yet, from far away, the universe around a black hole can remain surprisingly orderly. Stars can orbit, gas can circle. Planets, at suitable distances, could theoretically continue their paths. This is why the idea of a planet around a black hole is not as impossible as it first sounds. Imagine a cold world moving through darkness, following an invisible gravitational center. There may be no familiar sunrise. There may be no bright star warming its surface. But if there were enough surrounding material and enough energy from the region around the black hole, the planet's environment could become surprisingly complex. Such planetary systems have not been directly confirmed around black holes, so this remains a possibility rather than an established observation. And it is perhaps better to leave it that way for tonight. A possibility, a quiet world moving around an invisible center. Farther away, some black holes are born from the deaths of massive stars. When a sufficiently massive star reaches the end of its life, its core can collapse under gravity. The outer layers may be expelled, while the remaining core becomes extraordinarily compact. If enough mass remains concentrated in that small region, a black hole can form. The star that once filled an enormous volume of space is reduced to something far more compact. Its history remains in the objects around it. Its gravity remains, but the familiar star is gone. Other black holes are vastly larger. At the centers of many galaxies are supermassive black holes, objects containing millions or even billions of times the mass of the Sun. And now you can begin to imagine the center of our own galaxy. The Milky Way is enormous, but at its heart is an object known as Sagittarius A star. It is the supermassive black hole at the center of our galaxy. Its mass is about 4 million times that of the Sun. From our distant position within the Milky Way, it is far away. Yet thousands of stars move through the region around it, tracing their quiet paths through a crowded galactic center. Some of those stars move so quickly and so close to the black hole that their paths provide valuable evidence about the invisible object at the center. Astronomers have watched these stars move for years. They do not see the black hole itself as an ordinary bright object. Instead, they watch the stars. They measure their positions. They follow their orbits. And from those slow movements, they can infer the presence and enormous mass of the hidden object. Eventually, in the year 2022, astronomers were able to produce an image of the immediate environment around Sagittarius A star using a worldwide network of radio telescopes. The image did not show a simple photograph of a black sphere. Instead, it revealed a glowing ring-like structure surrounding a darker central region. Light from hot material curved around the invisible center. The galaxy had, in a sense, shown us its heart. You can imagine drifting farther away now. The black hole becomes smaller. The glowing material around it becomes a faint point. The stars of the galactic center begin to blend into the wider glow of the Milky Way. And the strange thing is that the black hole does not seem to have consumed the galaxy around it. The galaxy remains enormous. Stars continue to form. Clouds of gas continue to move. New worlds continue to appear. The black hole simply remains there, one deeply compact part of a much larger gravitational system. You can let that image become quiet, a dark center, a slow ring of light, stars moving through the distance, and beyond them, billions upon billions of other stars. The darkness around you is no longer empty. It is filled with motion that is simply too slow, too distant, and too quiet for your senses to notice. You have now seen planets circling stars, stars changing their forms, remnants compressed into tiny objects, and gravity becoming deep enough to hide light itself. But all of these things belong somewhere. They belong to something much larger, and as you drift away from the dark heart of the galaxy, the faint structure surrounding you begins to take shape. The stars are no longer scattered points. They are part of a vast home, a galaxy, and slowly, gently, you begin to see the Milky Way, not from within it, but from farther away. You can let the darkness of Sagittarius, a star, remain behind you. The glowing ring of material around the galactic center becomes smaller as you slowly drift away. The stars around it begin to spread apart. The crowded center becomes softer. And then, almost without noticing, you begin to see that the black hole was never the whole story. It was only the quiet center of something much larger, the Milky Way. From Earth, you know it as a pale band of light stretching across a dark night sky. For thousands of years, people could see that faint band without knowing what it really was. Some imagined it as a path across the heavens. Others gave it names connected with rivers, gods, or distant roads through the sky. Only much later did astronomy reveal the simpler explanation. The Milky Way is the combined light of enormous numbers of stars, most of them so distant that your eyes cannot separate them individually. You are now far enough away to see the shape behind that familiar band, and the shape is beautiful. The Milky Way is a barred spiral galaxy. At its center is a dense, elongated region of stars, surrounded by a much larger disk. From that disk, spiral arms curve outward. The whole structure turns slowly through space, not like a solid wheel. The stars are not attached to one another. Instead, they follow their own paths under the influence of gravity, moving through an immense collection of stars, gas, dust, and invisible matter. You can imagine the galaxy as a vast, slowly turning pattern of light. At the center, the stars are crowded together. Farther outward, they become more widely separated. And between them are enormous regions of gas and dust. Some of these clouds are cold and dark. Others are warmed by nearby stars and begin to glow. Some are places where new stars are being born. So the Milky Way is not simply an ancient collection of old stars. It is also a place of continuing change. New stars appear. Older stars fade. Gas drifts between them. Dust gathers. Gravity slowly reshapes everything. And the whole galaxy continues its quiet movement. As you move away from the center, the central bulge becomes easier to understand. It is a thick, bright concentration of stars surrounding the galactic heart. Many of these stars are old. Some formed billions of years ago, long before Earth existed. And passing through this crowded region is the galactic bar, an elongated structure of stars stretching through the central part of the galaxy. From our position on Earth, much of this region is hidden behind enormous clouds of gas and dust. The dust blocks visible light, but it does not block every kind of signal. Radio waves and infrared light can travel through some of these obscuring clouds, allowing astronomers to study parts of the galactic center that ordinary visible light cannot reveal. You can imagine this as looking through a very thick mist. The landscape is hidden, but occasionally another kind of light finds a way through. And then, slowly, the central region begins to fade behind you. The galaxy opens outward. The bright concentration of stars becomes less intense. The spiral arms begin to appear. These arms are not rigid roads through space. They are broad regions where stars, gas, and dust become more concentrated. They are also places where new stars are often born. Imagine drifting through one of these regions. The darkness around you is no longer completely dark. There are faint clouds, softly glowing nebulae, young stars shining with blue-white light, tiny particles of dust drifting through enormous spaces. The clouds can remain for millions of years, slowly changing shape as gravity gathers some regions together and disperses others. And from these clouds, stars can begin to form. A star may spend its earliest years inside a cluster of other young stars. But these clusters are not always permanent families. Over time, the stars slowly separate. Gravity from the rest of the galaxy gradually changes their paths. The young stars drift outward, becoming part of the larger galactic population. The Milky Way therefore carries the remains of countless generations of stars, mixed together in a slow, complicated pattern. And somewhere within one of these spiral structures is your own small neighborhood, the Orion Arm. It is sometimes called the Orion Spur, a smaller spiral feature located between larger structures of the Milky Way. This is where the solar system lives. You can imagine yourself drifting toward it now. The galaxy is still enormous. The sun is still only one star, but you can begin to recognize the neighborhood. There is the sun, there is Earth, there are the planets, and all around them, stars continue along their own paths. The solar system is not at the center of the galaxy. It is not close to the crowded galactic core. Instead, it occupies a relatively quieter region, tens of thousands of light-years from the center, within the broad disk of the Milky Way. That distance is difficult to imagine. Light itself would need many thousands of years to cross the space between our neighborhood and the galactic center. And yet, from Earth, the entire galaxy can appear as one soft band of light across the night. This is one of the strange gifts of distance. Things that are unimaginably large can become visually delicate when seen from far enough away. A galaxy containing hundreds of billions of stars can look like a faint ribbon. A star can become a point. A planet can disappear completely. And the spaces between everything remain almost invisible, even though they occupy so much of the universe. You can remain here for a moment, somewhere above the Orion Arm. The sun is behind you. The galactic center is far away. Around you, stars continue to form and fade. Somewhere, in a cold cloud, gravity is gathering matter. Somewhere else, a young star is beginning to shine. Somewhere far beyond your view, an old star is releasing the last of its outer layers. And all of it belongs to the same enormous structure, the Milky Way. But there is another quiet mystery here. When astronomers watch the stars move around the galaxy, they find that the visible stars and gas are not enough to explain all of that motion. Something unseen appears to be contributing additional gravity. We call this dark matter. You cannot see it directly. It does not shine like a star. It does not form familiar clouds of visible light, but its gravitational influence can be inferred from the way stars and galaxies move. You can think of it as an invisible presence surrounding the visible galaxy, something that cannot be seen, but whose gravity helps shape the motion of everything you can see. And perhaps that is a fitting thought to carry with you as you drift farther outward. The Milky Way is not only the glowing spiral you can see. There is much more around it than the stars reveal. The visible disk is only one part of a much larger structure, so you begin to rise slowly above the spiral arms. The bright disk stretches beneath you. The stars become thinner, the glowing band begins to flatten into a distant shape, and beyond the familiar spiral, the Milky Way continues into regions that are much older, much darker, and much more sparsely populated. The galaxy you thought you knew from the night sky is about to become larger than you imagined. You are now floating above the Milky Way. Below you, the spiral arms stretch outward in a wide, luminous pattern. The Orion Arm is somewhere beneath you. Far away, the galactic center glows faintly through the enormous distances between stars. And behind all of this, the familiar disk of the galaxy begins to look thinner. The farther you rise, the less crowded the stars become. The bright spiral structure slowly fades. There are fewer glowing clouds, less visible gas, more darkness. And yet, the Milky Way does not simply end where its bright disk becomes difficult to see. There is another region surrounding it, a much older, much thinner, and much quieter part of the galaxy, the thick disk. You can imagine it as a faint layer above and below the brighter spiral disk, populated mainly by older stars. These stars have been traveling through the galaxy for enormous stretches of time. Some formed billions of years ago, when the Milky Way looked different from the galaxy you see today. There was less of the familiar spiral structure. The galaxy was still growing. Smaller collections of stars were being gathered together. Gas was moving. Gravity was slowly shaping everything into the large structure that exists now. And some of the stars you see in the thick disk may carry memories of those ancient stages. They are old lights, quiet lights, stars that have remained long after many of the clouds and clusters from which they were born have changed beyond recognition. As you drift farther upward, the stars become more scattered. Now you begin to notice small, rounded groups of light. These are globular clusters. They contain many stars gathered together by gravity, often in dense, almost spherical arrangements. Some of their stars are among the oldest in the Milky Way. Imagine looking toward one of these clusters from a great distance. Instead of one star, you see a faint, glowing cloud. But within that cloud are countless individual suns, bound together in a slow gravitational dance. Many of them have existed for more than 12 billion years. That means some of their light began its journey before the solar system existed. Before Earth, before the Sun had formed, before the familiar planets had taken their present shapes, the stars simply continued shining. And now, billions of years later, their light is still crossing the darkness. You can let that thought move slowly through your mind. A very old star. Still shining, still moving, still part of the galaxy. But the halo around the Milky Way contains something else. Something that looks less like a cluster and more like a trail. Long streams of stars can stretch through the space around the galaxy. These are stellar streams. Some are the remains of smaller galaxies that once passed close to the Milky Way. Gravity slowly pulled at them. Their stars were separated from one another and stretched into long, delicate structures. Instead of remaining together as a small galaxy, the stars became a thin stream winding around the larger one. One well-known example is the Sagittarius stream. It contains stars that are thought to have once belonged to a smaller companion galaxy. Over enormous periods of time, the Milky Way's gravity gradually drew those stars outward, stretching them into a long trail around our own galaxy. You can imagine it as a faint ribbon of stars, almost invisible against the darkness. Not a straight line, not a rigid structure, a slow, curved stream, following the gravitational shape of the galaxy. And this tells you something important. The Milky Way did not simply appear as one enormous galaxy and remain unchanged. It has grown. It has absorbed smaller systems. It has rearranged their stars. Some of the stars around you may have been born somewhere else. They may have belonged to another small galaxy long before becoming part of the Milky Way. In this way, a galaxy can carry pieces of its past within its present form. Somewhere else in the halo, another small galaxy is being pulled apart. Its stars are gradually being stretched away from one another. Gravity does not need to act quickly. Given enough time, even a small difference in gravitational pull can reshape an entire collection of stars. Millions of stars can become a stream. A small galaxy can become part of a larger one. And a galaxy can quietly grow without anything happening that a human observer would notice in a single lifetime. You continue drifting upward. The bright Milky Way is now far below you. The stars of the disk form a thin, luminous plane. Around you, there is much more darkness. But even here, the space is not completely empty. The halo contains extremely hot gas. It is so hot that it can reach temperatures of millions of degrees, although the gas is spread very thinly through space. You would not feel a warm breeze. There is not enough material for anything like that. Instead, this hot gas forms a vast, faint environment surrounding the galaxy. It is almost impossible to see with ordinary eyes, yet it is there, a huge, thin atmosphere around a galaxy. And beyond the visible stars and the faint gas, there is an even larger component. Dark matter. You cannot see it directly. There is no soft glow to follow, no cloud to photograph, no ordinary light reflected from its surface. Instead, astronomers infer its presence from gravity. Stars orbit the galaxy. Galaxies move within larger groups. Light bends as it passes through massive regions of space. Again and again, the motion of visible matter suggests that something unseen contributes to the overall gravitational structure. So you can imagine the Milky Way surrounded by an enormous invisible halo. The bright spiral disk is only the part you can easily see. The invisible structure extends much farther. You cannot look at it directly. But without something providing that additional gravitational influence, the motions of stars and galaxies would be difficult to explain. It is one of those places where astronomy asks you to imagine something you cannot see, not because the idea is magical, but because sometimes the effects of an invisible thing are easier to observe than the thing itself. You can remain here for a while, the galaxy below you, the old globular clusters around you, the faint stellar streams slowly wrapping through the darkness, the hot gas spreading thinly through the halo, and the invisible gravitational structure extending farther still. The Milky Way that once seemed so enormous from Earth now appears almost delicate. A bright disk, a faint surrounding halo, and beyond it, more darkness. You have traveled far enough that the galaxy is beginning to look less like a place and more like a single object floating in space. And now, as you drift still farther away, the Milky Way slowly becomes smaller. The spiral arms become difficult to distinguish. The central glow fades. The halo disappears into the surrounding darkness. And eventually, there is only one small galaxy of light behind you. Not the universe, not even the largest structure. Just one galaxy among many. Somewhere ahead, another galaxy is waiting. The Milky Way is becoming smaller behind you. The spiral arms are no longer easy to distinguish. The bright center has faded into a single soft glow, and the enormous halo that once seemed to surround the entire galaxy has almost disappeared into the darkness. For a moment, you might think that you have finally reached empty space, but then another point of light appears, and then another, and another. The darkness around you is not completely empty. There are other galaxies here. One of the largest and most familiar is Andromeda. From Earth, Andromeda appears as a faint, soft patch of light in the night sky. It is so far away that its individual stars cannot normally be seen with the unaided eye. Yet from here, farther outside the Milky Way, you can begin to imagine its enormous shape, a galaxy, another island of stars. Another vast collection of gas, dust, planets, stellar remnants, and invisible matter. The distance between the Milky Way and Andromeda is about 2.5 million light-years. You can let that number become an image rather than a calculation. Imagine light leaving the Milky Way. It travels for 1 year, then another, and continues onward for more than 2 million years before reaching the other galaxy. During all that time, there is no bridge between the galaxies, no road, no cloud of matter filling the space, only a very thin sprinkling of particles spread through an enormous darkness. The space between galaxies is far emptier than the space between the planets, and even the space between stars, which seemed so vast earlier, now feels almost crowded by comparison. You drift across this distance slowly in your imagination. The Milky Way becomes smaller behind you. Andromeda becomes slightly larger ahead. Neither galaxy is rushing toward the other in any human sense. Their motion unfolds across immense stretches of time. Gravity is quietly shaping their paths. And neither galaxy exists completely alone. The Milky Way, Andromeda, the Triangulum Galaxy, and many smaller galaxies are bound together by gravity. Together, they form what astronomers call the local group. It is our small neighborhood within the much larger universe. There are many galaxies here, but only a few large ones. The rest are mostly smaller companions, including faint dwarf galaxies that can be difficult to observe. Some circle the larger galaxies. Some have been pulled apart, some may have been absorbed over time, and some remain quietly orbiting at great distances. You can imagine the local group as a loose gathering of islands in an immense dark sea. The islands are galaxies, the sea is space, and most of the sea contains almost nothing. As you continue drifting outward, even the local group begins to look small. The Milky Way and Andromeda become 2 points of light among many others. The triangulum galaxy becomes another faint point. The smaller galaxies become increasingly difficult to distinguish. And then, something even larger begins to appear. The galaxies are not scattered completely at random. They gather into broad arrangements, long structures, and flattened regions. Our local group is part of one of these larger arrangements, known as the local sheet. It contains many galaxies spread across an enormous region of space. From this distance, the structure can be imagined as a very thin layer of galaxies, floating within a much larger darkness. The galaxies are separated by vast distances, yet gravity still connects their motions. The universe, it seems, is not simply a box filled with randomly scattered stars. It has a pattern. Galaxies gather. Galaxies stretch into broad structures, and between those structures are enormous regions where galaxies become much less common. You are beginning to approach one of these regions now. The light around you becomes thinner. The galaxies become fewer. The darkness becomes larger. This is the local void. The name sounds simple, but the scale is difficult to imagine. It is an enormous region of space with far fewer galaxies than the surrounding areas. It is not perfectly empty. There are still galaxies within and around it. There is still thin gas. There is still gravity. There is still the slow expansion of the universe. But compared with the richer regions around it, the local void is unusually sparse. You can imagine standing inside an enormous room where only a few tiny lights are scattered across the walls. The room is not completely dark. It is simply mostly empty. And now the strange thing becomes clear. The void is not merely a blank space left over after everything else was created. It is part of the cosmic structure itself. Long ago, when the universe was much younger, matter was not distributed perfectly evenly. Some regions contained slightly more material. Others contained slightly less. Over enormous stretches of time, gravity pulled matter toward the denser regions. The richer regions became richer. The emptier regions became emptier. Galaxies gathered into groups and filaments. The spaces between them expanded and became increasingly sparse. The emptiness was slowly shaped alongside the galaxies, so the universe grew into a pattern of light and darkness. Matter gathered into threads. Galaxies gathered along those threads, and between them, great spaces opened. You can remain inside this idea for a moment. A universe that creates both things and spaces, stars and darkness, galaxies and voids, light and distance. Nearby, within the broad region of the local void, there is a small spiral galaxy known as NGC 6503. It is much smaller than the Milky Way. Its spiral arms contain areas of bright gas and young stars. Some regions glow with the light of newly formed stars. Other regions are darkened by cooler gas and dust. And yet this small galaxy exists within a region that is otherwise unusually sparse. You can imagine it as one little island of light surrounded by a vast, quiet sea. It is a useful reminder that even the emptiest regions of the universe are not perfectly empty. There are still exceptions, still isolated galaxies, still stars being born, still light moving outward, still time passing. And beyond this small galaxy, the local void continues. Its scale is so large that the idea of crossing it becomes almost meaningless. You would need millions of years for light to travel across some of its greatest dimensions. And even then, the journey would be mostly through darkness. No long chain of stars would guide you. No bright galaxy would appear at every step. For a very long time, there might be almost nothing to see. Perhaps only a faint point of light somewhere far ahead, then another, then nothing again. This is where the meaning of emptiness begins to change. Earlier, when you left Earth, emptiness meant the space between planets. Then it became the space between stars. Now, emptiness exists between galaxies, and the scale keeps growing. You are no longer moving between worlds. You are moving between entire galaxies. The Milky Way is behind you, Andromeda is somewhere within the larger group. The local sheet stretches across the darkness, and the local void opens quietly beside it. The universe seems less like a collection of objects now, and more like a vast arrangement of light, separated by enormous spaces. You can let yourself drift here. There is nowhere you need to reach. There is no destination waiting urgently ahead. Only more darkness, more distant galaxies, more faint structures, and beyond the local group, beyond the familiar neighborhood of the Milky Way, the pattern becomes larger still. The threads become longer, the spaces become wider, and the quiet emptiness begins to occupy more and more of what you can imagine. The darkness around you continues. The local void stretches quietly behind you now, a vast region where galaxies are separated by enormous distances. The Milky Way is far away. Andromeda is far away. The small galaxies of the local group have become tiny points of light, and then even those points begin to fade. For a while, there seems to be almost nothing ahead, just darkness. But as you drift farther outward, something begins to appear. Not a single galaxy, not even a single group. A pattern, very faint at first. Small concentrations of galaxies gather together, separated by broad spaces. Then those concentrations seem to connect. Long structures begin to emerge, threads of galaxies stretching across the darkness. These are part of what astronomers call the cosmic web. You can imagine it as an enormous, almost invisible network spread throughout the universe. But it is not a web made of threads you could touch. Its threads are made of galaxies, gas, and the gravitational structure that has gathered matter together over immense stretches of time. Where matter became slightly more concentrated in the young universe, gravity slowly pulled more matter toward it. Those regions became richer, galaxies formed, groups of galaxies formed, clusters formed, and between them the universe remained more empty. Over billions of years, this difference became larger. The rich regions grew richer. The sparse regions became more spacious, and the universe gradually developed the pattern you are seeing now. Threads of galaxies, broad sheets, dense clusters, and enormous voids. The strange thing is that the empty spaces can be much larger than the galaxies themselves. A galaxy may be tens or hundreds of thousands of light-years across. A cluster may contain thousands of galaxies. And yet the distances between these structures can stretch across millions or even hundreds of millions of light-years. You can let that scale become softer rather than trying to calculate it. Imagine a handful of tiny lights scattered across a dark room. Now imagine that the room is so enormous that the lights themselves are separated by distances that light needs millions of years to cross. That is the kind of emptiness you are moving through. And still, there is structure. The galaxies are not simply scattered randomly. They trace the invisible architecture of gravity. Some gather along long filaments. Some collect where several filaments meet. Some remain near the edges of enormous voids. And some appear almost alone. You can imagine one small galaxy sitting quietly at the edge of a great empty region. Around it, there may be almost nothing. Yet far away, perhaps millions of light-years beyond, another galaxy shines. Its light begins its journey. It crosses the darkness. And eventually, perhaps, it reaches another galaxy. The universe is connected by light that travels through almost nothing. This is one of the quietest ideas in astronomy. The farther apart things are, the more time their light needs to travel between them. So, when you look outward, you are also looking backward. A nearby galaxy is seen relatively close to its present time. A galaxy billions of light-years away is seen as it existed billions of years ago. The farther you look, the younger the universe appears. You are not simply traveling across space. You are drifting backward through time. And eventually, there is a limit to how far that view can reach. The universe has been expanding for billions of years. Light has been traveling through it. And because light moves at a finite speed, There are regions whose light has not had enough time to reach us. The part of the universe whose light can, in principle, reach us is called the observable universe. The word observable is important. It does not necessarily mean that the universe ends there. It simply marks the region from which information has had time to reach us since the early universe. Beyond that boundary there may be much more, perhaps vastly more, but we cannot see it directly. You can let that boundary remain distant and gentle. There is no wall, no edge you could touch. Only a limit created by the travel of light and the age of the universe. And as you drift toward the farthest light we can observe, something remarkable begins to surround you. A very faint glow. It does not come from a nearby star. It does not come from a galaxy. It is older than the galaxies around you. It is the cosmic microwave background, a faint remnant of the early universe. You can think of it as an ancient afterglow, a very old light that has been traveling across expanding space for billions of years. By the time it reaches us, it has become extremely faint and shifted into a form of radiation that cannot be seen with human eyes. But instruments can detect it, and within that faint background are tiny variations, very small differences in temperature and density. Those differences are important because they represent the early seeds from which the later universe grew, the galaxies, the clusters, the great filaments, the enormous voids. All of these structures developed from a universe that was once much younger, much hotter, and much more uniform. You can imagine the early universe as a nearly smooth field with tiny irregularities. Almost nothing seems different. And yet, over immense stretches of time, gravity slowly amplifies those small differences. A little more matter here, a little less matter there. A slightly denser region begins to gather more material. A slightly emptier region loses more material to its surroundings. And billions of years later, the cosmic web appears. Galaxies shine along its threads. Clusters gather at its intersections. Voids open between them. And the entire pattern continues to change. You have now drifted farther than any human body could ever travel. You have passed beyond Earth, beyond the planets, beyond the nearby stars, beyond the Milky Way, beyond the local group, beyond the great empty spaces around our galactic neighborhood. And yet, after all that distance, the universe does not feel louder, it feels quieter. The farther you go, the more darkness surrounds the light. The more enormous the distances become, the more gently everything seems to move. And now you can begin to drift back. Not because the universe has changed, but because you no longer need to travel farther. Let the distant cosmic web remain behind you. Let the ancient afterglow continue crossing space. Let galaxies continue turning. Let the voids remain vast and quiet. You can slowly return your attention to the Milky Way. It becomes a faint shape again. Then a smaller glow. The spiral arms return. Somewhere within them is the Orion arm. Somewhere inside that arm is the solar system. And somewhere within the solar system is Earth, your home. You do not need to imagine the entire journey back. You can simply let the distance disappear. The Milky Way becomes the night sky. The night sky becomes the window becomes the room around you, and now there is no need to think about galaxies or black holes or distant planets. They can continue without you. The stars can continue shining. The planets can continue turning. The galaxies can continue drifting through the cosmic web. The enormous empty spaces can remain empty. Everything can continue moving slowly, quietly, patiently. And you can become still. There is nothing you need to solve, nothing you need to remember. You have already traveled far enough. So perhaps you can simply listen to the quiet around you. Feel the weight of your body resting where it is. Notice the darkness behind your closed eyes. Let your breathing become slow and natural. And somewhere far beyond your room, ancient light is still traveling. A faint message from the early universe. crossing an almost unimaginable distance, arriving quietly. You do not need to follow it anymore. You can let it continue on its way. The universe is large enough to carry its own stories, and tonight you can simply rest beneath them. And so, our journey drifts quietly to its end. Whether you are still listening beneath the soft glow of your screen, or already floating somewhere between dreams and distant stars, thank you for traveling here tonight, through silent worlds, ancient stars, dark galaxies, and the immense spaces that lie between everything. If this wandering brought you a little calm, you are welcome to subscribe or share it with someone who could use a gentler night beneath the cosmos. For now, rest well. The stars will keep burning, the planets will keep turning, the galaxies will keep drifting, and the universe will carry on softly around you while you sleep.